Hello, everyone, and welcome to episode 167 of the Citrix session. I'm your host today, Bill Sutton with XenTegra. Also with me today are two folks from Citrix, Jeremy Myers and Todd Smith. They're regulars on this podcast. Todd, you want to say hello to everyone, and then following that, Jeremy.
Sure. Hey there, Bill. Hey, Jeremy. It's been a while since I've been able to join this podcast, but looking absolutely forward to this topic. As you know, I'm a former Ardence SE, and
Right.
PVS is always going to hold a special place in my heart.
Yep, understood.
When we first talked about this, Todd, it did not occur to me that you were a PVS OG, and now it's all making sense. Is it too late to switch? You know what? It's too late. I guess we're going to
Yeah.
roll with this one.
We're stuck with it, Jeremy. So it's all good. It's all good. Yeah, the title of the blog we're going to be discussing is Pure PVS Provisioning for Pacesetting Public Sector Purposes. That's a lot of the letter P. So nevertheless, Pure PVS Provisioning for Pacesetting Public Sector Purposes by Jill and Shane Smith. So that's the article that we're going to be talking about. It's pretty short, but I'm sure we'll have a good conversation among the three of us here. What Jeremy Myers was alluding to is the technology provisioning services that is part of the Citrix stack these days, or has been for a while, was created or obtained through an acquisition a number of years ago from a company in Massachusetts called Ardence. And the illustrious Todd Smith on this call was a part of that. I remember this, remember this from way back because I was flown up. I was with another partner at the time, and I was flown up to Massachusetts to learn this technology. And I think, Todd, you were one of the instructors. Is that?
I was. I remember that day, and then and soon afterwards, my sales rep and I went down and we did a tour of Virginia with Bill and his prior employer.
Right.
Yeah, I look back at it and think, 18 years ago, I got a phone call from a former manager, mentor, and friend that said, "Hey," and he said in his best Texas twang, he said, "Hey, Tiny, I got a job opportunity for you. Why don't you come over and have dinner with me?" And he happened to be up in Massachusetts, and I said, "Sure, Brew. We'll got a chance to see some of the technology and see how it could solve a lot of problems. If you remember back in the day, you used to have to ghost machines
Oh, yeah.
and do manual CD-ROM based installs of operating systems. And in some cases, you have to also do like diskette installs of, everything from Windows 3.5.1 and Windows 4 all the way up to Windows Server, early 2000 versions. But great technology. And, I think this blog, and we'll get into it, it's really kind of hits to the root and the foundation of what provisioning services can do. And it's also kind of a mistaken or underappreciated use case that we can certainly talk about.
Hey, real quick, fun fact, Todd, how many floppies did it take to stand up Windows NT 3.1?
They sent like 120 of them in a box. And the ironic thing is that there was a timeout that occurred. So you have to pretty much have them in order when you're when you're doing the diskette shuffle. And then they came out with portable CD-ROM drives that you could plug in. It didn't give you any much more help, but it eliminated having to do the diskette shuffles.
So NT 3.1 came out in 1993. I'm going to date everyone here, and I'm going to say that was the year that I graduated. No, that I started high school. That was my 10th grade year. There we go. 31 years ago. So there we go. 22 floppies. 22, what did we call them back then?
1.25, 1.4 meg, the little plastic ones.
The little plastic ones. Yeah. I hope they all worked. So listen, what's interesting about Ardence, much like Citrix, and the fact that if you go under the hood, you go into the registry, you start looking at files, you can see just remnants of old Citrix technologies that have gone away but still stick around. Dazzle is the one that we like to talk about because Such a fun name. And
WFICA.sys.
oh
Right?
yeah, yeah, yeah.
Yep.
And the boot file for PVS is still to this day. What is it, Todd?
ARDBP32.bin.
bin. Yeah.
.bin. That's right. So it's still that Arden's 32 boot file. That's wild.
So this trip down memory lane is making me smile, of course, but for those on the call who have no reference point to this, let's talk a little bit about what Ardent/provisioning services can do. And I'll start by reading the first sentence of the blog that we're covering, which is, did you know you can stream a desktop to an endpoint using PVS alone? The answer to that's yes, obviously. Well, it may not be yes in the sense that the reader knows that, but it is a true statement that you can do this. Todd, you want to talk a little bit about like the foundations of PVS and Ardent's, what it actually did, and kind of a general idea of how it worked?
Sure. So this all started with one of our U.S. national laboratories had a problem where they needed to get rid of local hard drives on endpoint devices, right? So they did everything from looking at, pluggable drives and having the drives taken out every once in a while. And they needed a way to basically boot the machine without having the risk of a local hard drive that can be either corrupted, stolen, or whatever, but needed to be updated. So provisioning service was really built out of that specific use case of how do I boot something off of a network, right? So leveraging a tool that's built into every chipset called PXE, which is a pre-executed environment. Basically, what you can do is instead of pointing to a local hard drive, you actually point to a network location that holds the disk content and then drops it down over the network connection as needed, right? So it loads the network driver, it loads the connector out to the boot sequence, and every time the operating system goes to read from the disk, instead of reading from a local drive, it actually goes out to this network location. Very simple way to describe it, but it's very effective and very efficient. Reason for that is because it leverages a lot of the way the operating system would normally read from the disk drive locally, right? It reads a block at a time and loads that into memory as needed. And then when it's not needed anymore, it pulls it out of memory and gets the next block. So very efficient, it really works well over a local area network. Oftentimes it works well in a data center environment. So it can be used for that same technology can be used for both desktop operating systems, such as the Windows 11, Windows XP, Windows Vista, but it can also be used on server-based operating systems.
Yeah, and that was one of the key reasons that Citrix acquired it, right? The ability to, because historically, if you go back to when, what was it, 2006?
So Citrix acquired Ardent in 2008.
Okay.
Yep.
Okay. Yeah, looks like it was announced. The agreement was announced, and according to Wikipedia, it was announced in December of 2006, but I think it took a little while for them to get everything done. But back in those days, in the 2007, 2008, if you had a large what was then called probably presentation server, maybe it might have been called XenTegra then. I don't recall.
Yeah, so a lot of the reason for this was we had a lot of customers. Citrix had a lot of customers that were running into consistency problems across their server farms, right? And a server, if you had 4 servers in your farm, the likelihood of all 4 servers being identical in terms of drivers, workloads, applications being installed, configuration settings, and things like that, they could be all different. And that created a lot of havoc when you started doing things like application load balancing, because you expected the servers to be at the same level, right? And that not only caused problems from an operational perspective, but it also caused a lot of problems from a audit perspective, an audit and compliance perspective. And you got to remember that this is right around the same time that Sarbanes-Oxley and Section 402 came out, where you needed to make sure one of your controls was that you have consistency across your application stack and your hardware stack and things like that. So it was really kind of the perfect storm of being able to say, we need the technology because we've got requirements that are forcing us to go this direction. And then we also have a technology that can actually help improve the operational aspect of it and make it easier on administrators.
Yeah, I mean, I can remember in this time frame, around 06 or 07 in particular, we had a couple of large healthcare customers that had pretty significant presentation server farms. I mean, hundreds of physical servers. This was before virtualization had started to really take off, or right around the time it was going to take off. And they would use either something like Ghost. There was a product called PlateSpin where you could build out a DVD or a CD and just pop it into each one of the servers, turn it on, and it would immediately load an image you had created and generalize it and make it available. The problem with that was once you'd done 100 servers with PlateSpin and had them all ready and allowed users to get on them, they were immediately going to start drifting. Like Todd said, they wouldn't be consistent. And with the Ardent/provisioning server product, you had the ability to create a single image and then stream that over the network to RAM, if you will, across the network to these devices. And then if you needed, like Todd was saying, if you needed to stand up 10 new servers, you literally just added the objects in the provisioning services console, set the servers to boot off the appropriate bootloader file, turn them on, and they would all boot up and have the exact same image that the rest of the servers did when they booted. So it was a pretty significant advance in delivering consistent workloads to your XenApp or your presentation server XenApp CVAD users, because you could create a single image and deliver it to many servers. And obviously, once virtualization came along and we could do this on something like XenServer or VMware, it obviously made it even better because you no longer had to worry about the same exact hardware being in all of your physical devices.
Actually, you bring up a really good point, Bill. So when Citrix acquired this technology, like we weren't talking about virtual machines. We were talking about physical servers. In fact, we did a synergy probably that year of the acquisition. So 2008, 2009, maybe, where, the use case on stage was, we had an Ardent farm, we had a provisioning server farm,
Right.
and we were streaming the OS to some pizza boxes. So some rack mount servers running probably web servers. I can't remember. I don't think it was SQL. That wouldn't have made sense. But either way, in the demo was, watch this. I'm going to start yanking the hard drives out of these servers just to prove the point that we weren't using the hard drives on the servers, which was kind of interesting. But one of the use cases, and I haven't seen this in a while, which is what I love about this blog post, is typically, and we've got some very large deployments, like thousands of users, where we're using PVS to stream the OS to virtual machines. But this use case that I haven't seen in a while, which is awesome. In fact, I've got a handful of customers of different types that are spinning and streaming the OS to a physical endpoint.
Yep.
Going back to what Todd said, this is a security play here. The idea that there is no physical disk on an endpoint that I need to be concerned about. I am just streaming the OS, and when I turn it off, there's nothing left behind.
Exactly. Somebody steals that device or gets in the building and starts running off with them. There's no data on them. Yeah, you lose the device, but there's no data on them because it's all stored back in the data center on the master image.
Yeah, and I think there's a couple of really key use cases for this leveraging PVS to deliver to an endpoint. First was a secure endpoint where you didn't have to have anything locally installed as far as hardware goes. You literally had a network card that was connected to some type of fat PC that was rendered a thin client because of this.
Yeah.
So we had secure environments, but we also had education and healthcare in that mix as well. Because education, especially because oftentimes those computers in the labs were constantly being rebooted, or you'd have to have a lab specific for a math class or a science class with this, you could actually consolidate it and basically have different images or different workloads that could be streamed down based on a reboot. And then the other big use case was around call centers, where you had to have consistency across all of the different devices, and you needed to be able to have that quick turnover time. You didn't have to go and re-image or re-ghost a machine to be able to do that effectively and efficiently.
Yeah, we had I won't say what state, but I had a customer many years ago, not long after this technology came out. It was a DMV, Division of Motor Vehicles, the Motor Vehicles Department, a place we all love to go once every 10 years or whatever. We had a use case. They had the state we were in had these spread all over the state, of course. So the customer decided to put a provisioning server in each one of the branches, and then make all of the teller or the kiosk, the machines at the front desk, as well as some of the back machines, all boot off the same image. That way, everybody had the same thing, could access the same way, and they would update the images across the network, off the wide area network. It was a really good use case for it, and they used it for a number of years. I don't think they still are. They might be in some places, but they used it for a great number of years, and it was a huge advantage to them to be able to centralize the management of the images. If there was a problem, the user just rebooted, and that meant something, because literally it would go back to a known good functional state, and then they could manage the delivery of updates overnight or during a maintenance window. If there was a problem, they literally just flip it back from one image to another, and they're right back to a known good state very quickly. So definitely a huge advantage for the Division of Motor Vehicles. What I think a lot of folks don't realize, and part of why we wanted to do this blog, is that if you're a licensed, and keep me honest, guys, if you've got licenses for the universal license or the universal hybrid multi-cloud license, you have licenses for PVS. You can leverage them for your XenApp environment. And what this blog is essentially saying is that they can also be used as a standalone product to stream to a physical OS or a thin client, which is really what we're focusing on here. So, Jeremy, keep me honest here. Is that still the case?
So yes and no.
Okay.
Every edition of the Citrix licensing now includes PVS. So whether it's the private cloud, whether it's the universal hybrid multi-cloud, or whether it's the Citrix platform license. So you're included, PVS is included across the board. Now, what is only a part of the platform license is the ability to stream to a physical endpoint. And here's the other thing we haven't talked about yet. So this technology has also been ported into the cloud. So if you're running in Azure or GCP, you can also stand up and run PVS in either of those infrastructure platforms. So again, those three features, Azure, GCP, or even the physical endpoints, requires the platform license. However, all three versions do include, PVS for your virtual desktops.
Okay.
Yep. But listen, you hit on something I think we kind of forget. It's almost the secret sauce behind PVS. It's the versioning. The idea that, I mean, listen, I can't remember if Todd mentioned it earlier, but ghosting, holy smokes, how long did that take to re-image like a laptop in the past? I mean, I build the image, I push it out. I mean, that could take easily an hour, unless I, had it down to a science, right? But the idea here is, I could create there's a pretty amazing versioning system within PVS to where, I've got my production version of a disk that I'm using across all these endpoints. At the same time that I have created a snapshot of that guy, and I'm making changes to what I'm considering a version 2, if you will. And I'm testing that out. Maybe that's my test dev. It's really easy for me to flip and say, hey, start using this new one. And if for whatever reason, because this just happens, think Patch Tuesday, think CrowdStrike Tuesday, too soon for that, maybe. But, you got a scenario where you can roll back to either a previous version or known good state, like you mentioned. I think that's really the secret sauce, because it's instant. In fact, one of the other really slick demos that we used to do outside of the ones we did on stage was, there would be, granted, this was Windows XP, so this is kind of dates it a little bit, but we had a room full of 150 Windows XP. Of course, all you could see was the screens, but running Windows XP, and we rebooted it into, I want to say it was Linux, and then we rebooted back into Windows XP. So I think that video is probably floating around on the interweb somewhere.
Yeah. I actually already looked it up because I was thinking about that. Yeah, it's It's done to the tune of Sweet Georgia Brown, and if you Google Ardent's video, you will find it on YouTube.
Yeah, so a little history behind, a little quick story on that one. That was 255 machines booting simultaneously because we wanted to be able to show that you could do an entire Class C subnet, booting them up. And you started with basically booting up the machine into a Windows XP, upgrading them to a Windows 7 or Windows Vista at the time, and then be able to flip them over to, a portion of them went over to a Windows 7 or Windows 8 environment, and a portion of them went over to a Red Hat Linux distribution. And then we also were able to boot up SQL servers, an Exchange server, and a couple of IIS servers just to kind of round out the demo. And that was done really by one of our interns who took advantage of that video, replaced a 50-page paper that he was supposed to write to get credit for his internship.
So that's true. Huh?
Yep.
That's actually, I'd heard that story. I wondered if that was truth or legend. So
Nope. It was truth. We built that lab, and it was interesting. That was kind of what got us sold to Citrix.
Yeah.
Yeah. Because I think Mark Templeton and Chris Fleck and a couple of other folks saw the future in some of that technology. In, like we said earlier, that was originally used to do what was called the JUMP program, which was the Just Upgrade Me Please program, which was a, how do we get off of presentation server and up to 4.5 and eventually up to what's now referred to as XenApp.
Right.
I love that you guys did this for a Class C. I mean, that's so nerdy. It's fantastic.
Yeah. Yeah. Just again, Google Ardent's ARDENCE video, and you'll find it should be the first hit there. Ardent's 4.1 demo.
Yep.
Just play that. And that if the listener gets nothing out of this article other than go look at that video, you will have a good understanding of what you can do with PVS. Because what's in that video can still be done today.
Yes. So Bill, I think one of the things also in that video that you'll be able to see is it breaks up and creates a giant wall that basically becomes the Ardent's logo.
Yep.
And the way we did that is very critical to what sets us apart, what sets provisioning services apart from the other technologies like ghosting. Ghosting, if you remember, ghosting required you to do a sysprep after you've done the ghost, which then joins the machine into the domain, gives it all its unique IDs, and it sets the GUID, it sets all of the parameters that are now unique to that machine itself. We actually included that in our streaming service.
Right.
So built into the streaming service was what we referred to as personality, which could be machine name. It could be any MAC address or client name information that we needed to put in there. So think of it from all of the applications that require that information to be present for the machine to register properly into the domain and to get connected and do all of those admin type of functions. We were doing that as part of the stream. So we eliminated a major time capture or time hog that would actually be able to do that. So having that ability built into it was absolutely critical for us to be successful in streaming the operating systems, whether it be on a desktop OS or a server-based OS.
Yeah, I remember when we were learning the technology, we all of us were like, well, how's this going to work with a domain where you've got all these machines and they all have if you're booting up to say 10, aren't they all going to, if they're coming off a single image, aren't they all going to have the same name and the same MAC address? And I remember saying, no, you guys saying, no, that's not the way it works. We built the intelligence into it to name the machine, the name that you gave it in the console. And then there's some magic that happens with the machine account password between the provisioning server and the domain controller. There's lots of back-end communication that handle the joining of the domain and all those things. So truly, once you've once you've built out your image and set those parameters in the console, it just goes off and streams them down to the VM or the endpoint, and all the domain challenges that we would expect in doing that without sysprep are gone. All right, so it looks like we've covered the article pretty well. I just want to give you guys a chance to make any additional comments or any other clarity that we didn't quite cover. Todd, anything you want to cover here before we round this out?
Yeah. So one other thing that provisioning services keeps getting compared to is machine creation services, which are very similar image management capabilities that Citrix has. And customers are entitled to use they're entitled to use both MCS and PVS. One of the big things that we've now released is the ability to manage PVS images within the MCS consoles and the MCS management tools.
Oh yeah, that's relatively new, isn't it?
It's very new.
Mm-hmm.
It's one of the newer releases capabilities that's out. The benefit there is we understand that MCS may have a use case and PVS has a use case as well. It used to be a choice that you would have to make early on in your design of your infrastructure, the design of your deployment. Now you're going to be able to use both in there. And the other capability is you'll hear an awful lot is image portability, which is being able to take those images and migrate them up to Azure or GCP or other infrastructure components, right? So there's a huge benefit there, and this is something that has taken a little while to kind of pull together, but thanks to our product management team kind of rethinking the way some of these things can be done, and looking at it from an administrator's perspective and an architect's perspective, how to be able to make it more efficient and optimize that experience for not only the user, but also for the administrative team.
Absolutely. Jeremy, any other final thoughts?
No, Todd stole my thunder. I was thinking through how the integration points into Studio, starting to happen just to make it easier to manage. Also being able to use Studio as well to create the target devices, right? So there's always been a separate console for PVS, and a lot of this is making it almost invisible. Like there's still a streaming service and there's those sorts of things, but listen, at the end of the day, it's how easy can you make this to manage?
Yeah.
Given that you get two different approaches to image management, like Todd said, MCS and PVS.
Exactly. Yeah. So one thing I should point out for the listeners is if you read this article, you'll see it's very heavily mentions public sector workloads, which are absolutely critical to use this type of technology, but it is available to and works perfectly in commercial organizations. We at XenTegra have customers that are using PVS today to stream the VDAs or the workloads that users connect to. So it's 100% relevant to the commercial sector as well as the public sector, and certainly bears a look if you're not using it or you have a large environment that could benefit from it. The blog article does reference a tech brief that goes into more detail, so I encourage listeners to head to that. All right, so anything else, folks? Jeremy, Todd, do you guys have any final thoughts?
Yeah, it's good. It's good to see Todd. I haven't seen him in a while. It is good to see Todd.
Yeah.
Thanks for having on, Todd.
It has been, and I think you brought this up, Bill, is that instead of saying it's only applicable towards public sector accounts,
right?
It's really anyone who has a higher level of security requirement out there.
Yeah, true.
Or that will need the speed and efficiency and the protection of not having local hardware. I mean, this fits in local hardware devices such as, hard drives and the ability to lock down those endpoints. So really, if you're looking at thin client as an option, this is a great complementary technology towards a thin client approach.
Yeah, we had a client at one point that streamed the thin client OS to the endpoint and also streamed the PD or the actual server workloads. So they were using it for both in the same environment that really gave them a solid lockdown environment they could manage from a single point. So and security. From a security perspective, it's certainly enhanced that. So definitely a lot of benefits here. All right, gentlemen, thank you for participating today. We'll do it again next week.
Thank you.
Excellent. Thanks, Bill. Thanks, Todd.
All right.
Thanks, Jeremy. See you, Bill.
See ya.